So hi everyone. Today is gonna be our day 7 of the DSA challenge that we took. And the question that we're gonna do today is trait matrix. And this is the question that is on Leetcode. It's a medium level question, but it's fairly simple. So you don't need to worry about this tag. So this question has been asked in these many companies and these many times. So you can see. And also, I found out the extension that I am currently using. The extension name is called Big Omega, right? Big Omega. You can search on Google Chrome and you can probably add it in your browser. So question says that you're given an n cross n matrix, 2D matrix representing an image. Rotate the image by 90 degrees clockwise. You have to rotate the image in place, which means you have to modify the input 2D matrix directly. To not allocate another 2D matrix and do the rotation. Okay. So let's say that you are given a matrix 1, 2, 3, 4, 5, 6, 7, 8, 9, right? You have to rotate it in such a manner. Okay, can we do this? Let me see. Can I do this? Yeah, I can do this. If I rotate it in this manner, does it seem like so? Yeah, hope you will understand that this is our required answer. 741, 8, 5, 2, and 9, 6, 3. So I've rotated it 90 degrees, right? I hope this is the answer 90. Yeah, great. So this is what we require, right? And so what is the brute force solution? Okay, before even reading this line, before even reading this last line that is given that you have to do it in place, let's see what the brute force says. Okay, okay. So if I do this, if I just simply rotate it now, yeah, let me copy this and let me paste it here, right? So if we take another answer array, right, an empty array which has no values, it's a 2D array, it's going to be a 2D array, right, of same dimension that is n cross n. We need to set these values, right? We need to set these values. So where is one going? One is going here, two is going here, three is going here, four, five, six, 7, 8, 9, right? So this is how it's going. So if this is 0, this is 1, this is 2, 0, 1, 2. And similarly 0, 1, and 2, 0, 1, and 2. So if we say that 0, comma 0 is getting placed to 0, comma 2, right? Similarly, if we say 0, comma 1 is getting placed to, is it 1, comma 2? Yeah, it's 1, comma 0, comma 2 is getting replaced by 2, comma 2, right? Next row, if we see this, 1, comma 0 is getting placed at 0, comma 1, right? Uh, 1, comma 1 is getting replaced at 1, comma 1. 1, comma 2 is getting replaced at 2, comma 1. So do you see any pattern here? I mean, I have already seen it, right? So the pattern that we see here is that if this is I and this is my J column, do you see that this column is also J because this is going 0, 1, 2, this is going 0, 1, 2. I, J, this is going 0, 1, 2, this is also going 0, 1, 2. So this fairly means that this is J. Now let's see what this has to do, right? This is being constant here and this is also being constant here. This is being constant here and this is also being constant here. So one thing is it's simple that this value is going to change only once, right? So it has to do something with I because for every j value, I is going to be constant, right? So if you traverse the whole, basically, if you traverse the whole column, if this is I and you traverse all the elements of that row, J changes. J changes every time, but I remains constant. So that is for sure that this row has to do something with I. Do you see if I say n, oh sorry, if I say n minus 1 minus I. So if n is, what is n? N is 3 here. 3 minus 1 minus I, right? I is 0, right? So 2 minus 0 is 2. I here has become 1. So 3 minus 1 is 2. 2 minus 1 is 1. Do you see this? Yes. This is the example. So I hope that this is very easy. So if I have to give it a pseudo code, I'll say that I will run from 0 to n. Similarly, J will also run from 0 to n. I mean, not including n, or you can say till n minus 1, whatever. And you will say that, listen, my answer of I comma j will be nothing but, okay. So I'll say that my answer of um, j comma n minus 1 minus I will be equal to array of I j, because we have initiated a very an empty array, empty 2D array, so we don't need to do anything. We are not tampering the values. We are just setting all the values. And as you already know that in what do you call, in JavaScript, uh, the arrays are dynamic, so you don't need to do anything, right? So this is our brute force, right? What is the time complexity? Time complexity is always going to be n square because we are traversing two loops. And what is the space complexity? This is time complexity. Space. Space is going to be O of n square again. Why so? Because we are taking a new 2D array. But we need to solve this question optimally, doing in place thing, right? We need to change the place. We need to rotate the image in place. So that means that our space complexity somehow should be O of 1, right? Okay, great. So if I paste it again and see, right? Let me transpose, right? Now, what does transpose mean? So basically, if people who have already gone through engineering mathematics, they would probably know much better that what transpose basically means is that this, can I draw a line here? I can, right? If I draw a different color, and this is the diagonal, right? The diagonal has to be same, but these values, right? The other value, these values, they change, they interchange. This becomes here, so this becomes here. So to look like what a transpose of this would look like is, it would be, or simply you can say that this column will become a row, right? This column will become row. This column will become the last row. So 1, 4, 7, right? 2, 5, 8, and uh, 3, 6, 9, right? This is how the transport would look like, right? And if I select this, copy it, paste it somewhere here, and if I reverse every row, right? Reverse every row, it would look like 7, 4, 1. Also, just notice that in our transposed matrix, the diagonals are same, right? So 7, 4, 1, 8, very bad 8. 852 and 963. Is that our required answer? So if we go here, this is the same as this, right? Now the question arises, like how will you transpose? Okay. So see, if I start my I loop, right? So if this is zero, this is one, this is two, and this is zero, yeah, I cannot, right? Sorry, this is zero, this is one, this is two. I don't need to touch these values. So to exclude it, I need to start my I loop from this till this. Basically, it should basically my no, there's no problem in it. My let me say this. So if my I loop starts from this from zero only, my J loop should not touch one, should not touch five, should not touch nine. Or I can say, or I can simply say, I just change the color. If I can simply say that 4, 7, and 8, I just need to touch these three values somehow, or basically the upper half of the matrix, and simply just swap it with these values, right? Okay. So, to if I say that what is matrix of 0, 1, you will immediately say that it is 1. Sorry, it is 4, right? 0, comma 1, it's 4. Now, if I tell you that the matrix of 1, comma 0, you will say that 2. And don't I need to change this value with 2 only, right? If I swap my I j with j I, then I have done my part. Let's take this example as well. So if my array of 0 to is 7, right? So my array of 2, 0 will will have to be 3, and you will see the 2 comma 0 is 3, and you will see that I have to swap it with these two values only to get this type of array. So one thing is for sure that we are going to swap array of ij with matrix of ji, right? This is sure. Now to run the loop, I've already told you that my for loop should run as it was running previously also till n minus 1, right? Till n minus 1. Okay, great. Now I'll say that my for loop of j should start from I plus 1 and go till n. Now why am I saying? Just see, just see. I don't need to touch these values. I don't need to touch these values, right? I just need to touch these upper values, right? And if you notice that it starts from I plus 1, if my I is right now 0, then it starts from 1. If my I is 1, then it starts from 2. If my I had to be 2, it starts from nothing. I mean, it starts from 3, but 3 doesn't exist, so J loop won't run, right? So that is why this loop starts, and you need to swap it. And you need to swap it simply. And at the end of the day, you will just reverse each row, each, right? So in JavaScript particularly, there is a function for it, inbuilt function for it, that you will say that matrix of I dot simple reverse. It generally runs in O of n only. I have spelled it. So it runs in O of n by 2, which is, I mean, n only, uh, depending upon what you want to take it. So it's O of n by 2, right? I mean, I'm not calling it O of n, but we generally, when we take the time complexities, we ignore the constants, right? So let's jump on code now, right? So I'll say that, hey, um, let's start my I from 0. I will go till n minus 1, I plus plus, right? I'll say that, hey, let my j should start from I plus 1, and j should be less than m, and j should be incremental. Great. What is n? I haven't defined it. So n is nothing but matrix of 0 dot length. Rohan, why are you taking let m is equals to matrix dot length and make n as different value? Because it is n by n. So it doesn't matter. So rows and rows equals to columns, right? It's a square matrix. Now see, simply just swap matrix comma I comma j. I will make this function swap. Wait, let me enable this. Let's define this function swap. Wait, I'll say array. I'll say I'll say j, and I'll say let m is equals to array of I j, array of I j is equal to the problem of matrix array of j I and array of j I equals to 10, right? This is our swap function made in O of 1, so no problem. Before reversing, let's see what our matrix is. Okay. Dot log matrix and see if are we transposing it right or are we doing some mistake. Okay. So let's see what our transpose matrix will look like. 147, 258, and 369. 147, 258, 369. Is this what we require when we transpose it? Yes, right? So logic for transposing the array or slash matrix. Now, nothing, right? We just don't need to do anything. We are simply saying that, hey, just reverse every row since every row is an array itself, right? So I'll say that run a loop from I, I less than n, I plus plus, and a matrix of I dot reverse. I don't think we need to return anything in this particular question. Let's see if we need to do anything. If it's already accepted, then no problem. Okay, it's accepted. Both my cases are accepted. Let's quickly submit it, right? And you have to just do the rotation. Okay, you don't have to return anything. And maybe because we are doing in place, so it's taking that value only, and since it's passing by, it's passing here only. Great. We have an accepted solution. So it beats 89.28% of users. This question is done, right? From my side, I'll just add a note here. Optimize your brute force. Just take the transpose of the matrix given and reverse every row after transposing, after taking the transpose, right? This is our required answer. Great. I will save this. I will delete it, and I have already set it done. Great. We have done our day 7th question. Tomorrow we'll meet with another question called merge overload overlapping intervals. Very important question. Very, very important question. Um, so great guys. Thank you so much for joining in. I'll see you tomorrow with another question. Goodbye. Thank you.